This meeting is being recorded.
Okay, recording is up. All right, Cihangir, you can start.
All right. Okay, welcome everyone. First, let me introduce myself. My name is Cihangir Odabas, and I'm from the Asya Istanbul software development team. I'm also the team member and the team leader of OB2 team in the prplMesh work group. So today I prepared some demonstration with prplMesh for you. I hope you like it. Let's get started. Okay, so first of all, the slides are prepared for people who don't know the EasyMesh, but you already know very well. So I will not spend so much time on it, but I like this GIF so much, so I want to add this. So this is from the Wi-Fi Alliance webpage, and in this I mentioned that the version 4 is released and version 5 is on the way. Okay, and this next slide, I mentioned the features of different versions, and version 2 we have basic capabilities like onboarding, configuration, link metrics collection, client steering, data elements version 1, and version 3 we have DPP security and encryption features, and the version 4 we have advanced Wi-Fi 6 support, traffic queuing and shaping, and these are the general features of the versions. This is a general description of prplMesh, and you already know very well, and this is an open source implementation of Wi-Fi 7. And this is also interaction between different work groups like low-level API, northbound API, and high-level API. And also, as a roof, we use the prplOS, as you know. So again, this is a very quick description of prpl. So today, I want to mention my demo equipment. First of all, I have 3 GLI nets. And these devices are supported officially from the prplMesh, and it runs prplMesh version 3.0, and it runs prplOS, and it's the wireless drivers of it, the Qualcomm, but it's based on NL802 drivers. So this is open source. And I have secondly, this is a Netcan Wi-Fi pods, and this is EasyMesh R1 device from the retail market. And one of our contributors of prpl Foundation, which is T Networks, sent me one to do the tests, and thank you for them for sending me a couple of boxes. So I also tested a little bit interoperability with these devices. Okay, so this is my demo test setup. First, I have one gateway. It runs as controller. And I have 2 GLI nets connected with wirelessly, and the wireless backhaul is 5G. And this retail box is connected directly to the controller with Ethernet. So I have mix and match network topology in my test setup. So for the demo itself, I split the features so we can take a look at the demo easily. So first of all, we will discuss and see the onboarding and configuration part. And second, we will check the visibility, network topology. And thirdly, we will discuss diagnostics. And at the end, we will discuss a little bit optimization. Okay, the first part. So this is the initial configuration part. So when you bought lots of different boxes, you need to set the controller for one box, but you will use them as agent in other boxes. So most of the time, the devices will come with agent mode, not the controller mode, but you need to set the gateway itself. So let's see how it is done in the prplMesh. So as you know, the box is running prplOS. And in the prplOS, we have prplMesh section, and you need to specify the mode. And this is the gateway. So I selected as controller and agent. So this is the one option. You can select it from the web UI. And the second option is from the CLI. In the prpl OS boxes, we deploy some utility script, and it is under ATC, init, and prplMesh. So in this script, we can check the status of the prpl binaries, and also we can select the mode here, like the gateway mode, or you can write the repeater mode. So this is another option that we can select the mode itself. And the third option is the direct setting the UCI configuration. Let me show mine, prpl_mesh. So in here, you will see there is a one management mode, and you need to select its master and gateway. So these are the modes we use for the controller, basically. So I already set it up for the controller itself. And let me introduce a little bit what are the tools are when we use the CLI. The first of all, as you saw, that we have configuration, the UCI, and we also have utility script, and the most critical part for Nordband API, we use Ubus. And when we run the gateway only, this is what we came up with. So this is the initial data model look like. So we have one device in the network, so which is also controller and the local agent. We have two radios. One is for 2G and one for the 5G. So this is our initial data models look like. We have only one device in the network. Okay, let's move on. So this is our initial configuration. And second part, we need to create the Wi-Fi configurations for the network before we onboard. So how we do it? So again, let me open it. For access point creation, we have data models. So let me show my script for generating access point. So first of all, we need to add instance as part of the access point. My first access point will be responsible for front haul. So I set my SSID name as prpl_mesh, and I select each band as true. So what it means that these front haul configuration will reflect it on every band. So whenever a device is onboarded, it should reflect these as front haul. So I set my security mode, and I set my security key here. And secondly, I add another access point, and this one will be used specifically for backhaul. And this is a different SSID for backhaul, and again, I enabled it for all bands. Also, the security key can be different. There is another option that we can use. You can create different access points for different bands. So you can create different SSID names also for different bands, but I don't prefer it. Most of the case, we create one SSID, one universal SSID for mesh networks. So that's why I prefer. Okay, let me run the access point script. So it adds automatically the access point objects, and it selects my bands, it selects my security and key configuration. So, okay, I'm ready for creating access points and configuration. So initial configuration is done. The second part, we will onboard a device via WPS. So first I need to trigger WPS for controller, and then I will trigger WPS for the extender agent. So I give me a couple of seconds. I will go to the end of the hall, and I will click the WPS on the extender, and I will come back and click it on the controller. Give me a second, please.
Right. Maybe any quick questions so far that we can answer? Everything clear so far?
Okay, I'm back. So for triggering WPS for agents, we need to press WPS button for 5 seconds. And for controller, we click it only for 1 second. Why? Because we need to differentiate which one is hosting and which one is the joining. So we separated with some timeouts. So I clicked it. Let's see what's happening. Let me see. Okay, so this is my ping table. You can see it start pinging to the extender. So I can understand that it connected. Let me see what changes on the UBus. Okay, right now you can see radio 2 is added. It is onboarded automatically. What we do, only click the WPS. And you can also see that it creates the BSSs according to my first configuration from the controller. Let's check one of the values of the BSS. Let's call UBus call. This is device 2, radio 1, BSS1, and this is front haul. And as you can see, SSID is copied from the controller, and the BSS2 should be the back call. Yeah, it is. This is the prpLMesh back call. So I can also check from the 5G radio. Yeah, the 5G front haul is also prpLMesh. So it propagated the Wi-Fi configuration from the controller itself. So, all right. So we onboarded the device. My second step is the Wi-Fi configuration propagation. So even if we started devices with default settings, we can change the SSID and it should reflect it on the network. So in this case, first I want to add one device and then I change the configuration. So we will see that if it is reflected to device 2. So let me demonstrate that. What we need to write is, 1 second, sorry. Okay, let me change the SSID name to prpLMesh test. Okay, I changed the prpLMesh test and enabled all for all bands. Okay, I set it, but it is not reflected. I need to call access point commit. So what it does, it triggers the AP config renew procedure, and it says that to all extenders, okay, I changed the configuration, please request the new one. So after I clicked it, my ping should stop for a second because it disrupts the network for a second. Okay, you can see that pinging has stopped and continue. And we need to see that the new prpLMesh test is reflected. Let's see. Let me get from the BSS1 and device 1 first. Okay, you can see that SSID is changed. Let's wait a couple of more seconds to give the extender to refresh its own BSSs. Let me check. Okay, so this is device 2, radio 1, BSS1, and you can see that the prpLMesh test is reflected as the controller is. Okay, so I don't like this prpLMesh test name, and all my stations record the actual name. So let me revert back this name, and let's trigger another access point commit, and let's wait a couple of more seconds to the refresh itself. And let me check again the network. Okay. All right. Let me check the BSSs again. Okay, it's prpLMesh. All right. So what we did is we changed the SSID and it reflected to all extenders.
Just a question to confirm my understanding. So you use the data elements, network device, radio, SSID, both as a status field and as a configuration field, right?
The configuration is handled in the device network access point 1. We don't configure radio or BSS directly.
Oh, okay.
Yeah, that's why you need to select band. What it do is for example, you set the band 2G and you send it to the extender, and extender understands, okay, this should be reflected to my BSS1 because agent or extenders know that this is 2G.
Yeah, clear. Okay, I missed that part. Thank you.
Okay, no problem. All right, so and the last step, I want to add my other extenders to extend the network. So I need a couple of more seconds to trigger WPS on the third extender, and I will also add the wired extender to the network. I will be right back, sorry.
Yeah, in the meantime, if there's any questions that me or Adam or Rafael can answer about prplMesh, feel free to go ahead while we wait for Cihangir to return.
So can we use like same SSID for the front haul and the back haul in this setup?
Yeah, so Cihangir, we had a question. Can you use the same SSID for both the front haul and the back haul?
Yes, we can. So normally, let me open the access point object again. So you select the mode itself. So you can select either only front haul, you can select only back haul, or you can select front haul and back haul. So it is also supported. You don't have to create the front haul and back haul separately, but as far as I see from the devices on the field, they always separate it. I didn't ever see that one BSS for front haul and back haul. But it is possible according to standard and according to prplMesh.
Thanks for the clarification.
All right. So what I do, I click the, okay, let me open the network map again. What I do is I click the WPS on extender 1, and I click WPS on the extender 2 to connect two of them, because the third device, the extender 2, is very far away from my controller, and I can only link with these two. But I didn't connect to the Ethernet one. Give me a sec, I will be back.
Oh, I still have a question regarding this access point node. So I was checking, it doesn't seem to be part of the tier 181 standard, so it has been added by prplMesh, I guess. So do you know if it's planned to be added in a future version of tier 181?
Sorry, guys, I had to move. Can you repeat that, Silva?
Yeah, no problem. About the network access point node that you explained, I was checking, and I think it's not part of the current tier 181 standard. So
Yeah.
it has been, I guess, it has been added for the purpose of having a configuration node because none exists. And do you know if it will be added in a future version of tier 181?
Tim, do you know? Or maybe Arnaud was know it better, but normally there should be. There is a working group for managing the creating new data model for the Wi-Fi configuration. So this is not final yet, if I remember correctly. Maybe Tim can correct me here.
Yeah, what was the particular parameters?
Sorry, Tim, I didn't understand.
That what was he asked about particularly?
The Silva is asking, okay, right now we are setting the credentials over this access point object, but this is not part of the TR181. We added for specifically for prplMesh, but in the end, how are we going to do that? The Silva is asking.
Yeah, is that propagating it? Is that what it's doing? Because I mean, that's okay. Access point.
So this is the whole network credentials, not only one device. So this is, you can see that this is under network, not only not under device. But I remember there is a wiki page or discussion page under OB map group for specifically for configuration, right?
Right. Yeah. So if it's not in data elements, we're probably talking about it there. And yeah, the path we usually like to take is if we've got something we'll take it back to the Wi-Fi Alliance. But if they don't do it, we can always add it through a BDF extension. So.
Okay.
Okay,
If I find the link, I will send it to you, Silva. There was a specifically one page about the Wi-Fi configuration. All right.
Okay, thank you.
Okay, so I onboard all devices. So you can see the right top corner is the extender 1, right bottom is the extender 2, and left bottom is the Ethernet, the retail box. Let's check how our data models look like. So I add 2 more devices. One is the device 4 and one is the device 3. So it onboarded everything according to my connection automatically. For Ethernet, I didn't do anything. I just plugged the Ethernet and power off the device. But for extenders, I click WPS and that's it. So we finalize this onboarding and configuration part. Do we have any questions regarding this slide? So I will move on.
I have a question. Does it reflect in the Northbound API the connectivity lane, meaning that one device connected, the cascaded device connected to the other one?
So this is the other part, Adam. So this is a visibility and network map. While you are asking it, let me explain. So the first thing is we need to see the topology view, okay? Which one is connected to which one? So this is a very critical for us to determine what is the topology look like. So at the end, I have 3 GLINS and 1 NetCan, the retail box. Let me show you how we can determine the backhaul or the links between devices. So for that, we have one object under devices, multi-AP backcall. Okay, let me call it for the first device. What? Okay, I didn't write. You was call get. So this is the first device. So this is a controller. It doesn't have any backcall information. So that's pretty normal. When we call the device 2 multi-AP backcall, okay, so we can see right now the link between device 2 and the backcall device ID is the parent device. So this is our controller MAC. So the link between those is Wi-Fi. And our backcall MAC address is our parent BSS ID is the DA76. And our MAC address, this is the backcall MAC, which is backcall station MAC, is F4AD. Let's verify that. So 1 second.
So you said that the backhaul device ID, that's the
Parent
bridge?
agent. So this is the parent agent. So this is LMAC of the...
Yeah, LMAC, yeah. And the second field is the radio to which we connected.
Radio BSS, let's say.
Yeah, BSS.
And this is our own station MAC. So let's verify it. For example, so you must call, let's call the device 1 and get. So you can see this is the ID of device 1. So we can verify that, okay, this device 2 is connected to device 1. And let's verify the BSS ID now. UBus list, device 1, radio 2, because I know it uses 5G, I write it from my memory, and BSS2 is the backhaul. So let me call that. What did I do wrong? Okay, UBus list all. You can see DA76. What was my parent interface? DA76. So what it means that, okay, this device 2 is connected to radio to BSS2. Is that clear?
Yes, thank you.
And if we call that, if we see that station, let me also show you the station from that. You can see there is one station under this BSS. And if we call that station, you can see device 2, radio 2, BSS 2, and station 1 should be the MAC of the backhaul station. So we can also see this backhaul station on the network. And let's take a look of the device 3 backhaul. And it is reflecting device ID of the second device, so device 2. So this is an extender 1. And it says that it is Wi-Fi. This is its backhaul station MAC, and this is its parent's BSS ID. Let's take a look the wired one. Lastly, okay, it says that okay, my connection is Ethernet, and my parent is direct to the gateway, and this is also the bridge max. So for Ethernet, it's very simple. Okay, so the topology view. I can show the topology view, and I also show the hierarchy.
Cihangir, I think Dennis has a question.
Please go on.
I just wanted to, I just wanted to state that I think that this MAC address in the backhaul object is the last MAC address is actually the interface MAC, the BSS, the bstay address of the device, and that the address, the device ID is implied by where you are looking at, right? So you have to have a station in order to, you have to know what the station is in order to read the backhaul address. So that station is the implied station, and the MAC address that you see in the backhaul object is actually the or should be the actual address of the BSS, the MAC interface address for the looking up to the backhaul provider.
So okay, let me explain again. So this is our whole data model name, and this starts with backhaul. So what it means that okay, I have one device, and this is the backhaul object. And when you enter this backhaul object, first we have MAC address. What it means? Okay, this device has backhaul MAC, and which means that the backhaul interface of that device. And then if you add one more backhaul at the beginning of that field, it means that this is the backhaul device's ID. So this is our parent's ID, and this is also the parent's MAC. So this is the BSS ID of the parent device. Is that clear now?
No, it's always been clear to me. My only point is that the MAC address that 2 lines down from where your cursor is, that I thought I heard someone say that MAC address was the ALU ID of this object on which you're on, but that's not it. That's not right, right? This is the MAC address of the interface.
Yeah,
that's connected to the backhaul MAC address, right?
No, the comment that you heard was for the first field.
Okay, all right. So I'm happy to have misunderstood that part of the conversation. I just wanted to clarify that what this MAC address was. Thank you.
Okay. All right. Okay, so we discussed the backhaul link and hierarchy. We checked the topology view. So the stations are very easy actually. So I have one macro for stations. So I am searching the STA and the number, the digit from the network map. So I can see how many stations I have on the network. Okay, I have one station on the backhaul interface. These are BSS2. And again, this is BSS2, and this is another backhaul station. And I have only one station for the front haul. Let me check which one is. Bus call. This is probably my phone. Okay, so this is A8. So the stations are located under BSS as expected. So wherever they connected, we see that under BSS. So my phone is connected to device 4 this retail box, and I can also see that on the network where it is connected to. So this is very straightforward. So I don't want to spend so much time on it. Okay, so yeah, that's it for the visibility part. Do you have any question regarding visibility? Okay, move on. Diagnostics. Okay, so in this part, I want to share with you where are the diagnostics are, what do we have right now, and what will we have in the future. So I separated a little bit that, like, we have station traffic stats, we have station link metrics, station capabilities, backend measurement, interface stats, backhaul link quality, and radio capabilities, channel, operating class, etc. So I will not dig too much of it, but let's demonstrate a little bit what we have. All right, so as far as you can see that I search one station data model. Under it, the bytes and packets and the byte receives are part of the traffic stats, you already know. And the signal strength comes from the beacon measurements, and the downlink comes from the link metrics. So whenever we get these metrics from these extenders, we reflect to the data model. And in our controller, we have periodic call for collection for these stats. Some features triggered by the controller. Let's, for example, we can request the link metrics from extenders. And also we can set a policy that extenders send these stats periodically to us. So we have two mechanisms by collecting these stats. So these covers the station diagnostics, as you can see. Also, we can see the IP, hostname, etc. for that device station. What we have next? Beacon measurements. So beacon measurements, Ubus list. The beacon measurements are collected under measurement report. Let me find one. Okay, I need to add one more station to the network. 1 second, please. Okay, sorry about the delay again. All right, let me collect the stations again. Okay. Let's go. Okay, I have now two stations on my network. One is connected to device 3 and one is connected to device 2. I separate my phones between the office so they can connect which one is best for them. So one is connected to extended 2 and other one is extended 3. So let me check that I can see their name correctly. Okay, so this is Galaxy S20 and the other one. Okay, so this is my original phone. Okay, let me call Ubus list again. It should normally collect the beacon measurements periodically so we can see that measurement reports. Let me check that for a second. Okay, here. It was called failed to parse call. Not found. Perfect. So it is changed whenever we add a new measurement report, probably. So the number is incremented. Okay, so we get the third measurement report. Okay, so you can see that we have the RCPI, the connected channel operating class, and the connected BSS. This comes from the beacon measurement directly from station, and we add it as measurement report under these stations. So these are how we collect the beacon measurements and reflect to the data model. Okay. Interface stats. So interface stats is very, very simple, not that complicated, but under each device, we have interfaces, and these interfaces reflect the Wi-Fi and the Ethernet interfaces. And let me, okay, for example, in the device 3, we have one wired and 3 Wi-Fi interfaces. And if we call that the stats for these interfaces, let's call, and there is no connection on interface 4. Let's check 3. As you can see, some packets sent and received over these interfaces, and they're also collected over the topology messages. So this is for the interface diagnostics. So backhaul link quality. The backhaul link quality is very simple, that you need to check that backhaul MAC stations, the signal quality and the packets counters, and that's it. So they are actual normal stations to us. It doesn't change as other stations. Let us call the stations and check their backhaul link qualities. And what we have, okay, we said that the radio 2 BSS2 is backhaul and the station is the backhaul station. Let's check its parameters here. Because these devices are used for backhaul, it doesn't have any IP or host name. Just remind you that. You can see there is no IP address for these interfaces and there is no host name. But you can see our packets are received and transmitted over these lines, and you can see the signal strength. So this shows us the backhaul link. Okay, so the radio capabilities, channels, and operating class. So how do we separate 2G and 5G radios between them? So we only see that radio 2 or radio 1, but it doesn't mean to me anything. But when we check the operating class of these radios, I can differentiate the radios better. So let's check device 3 radio current operating class. It was called. It says that takes power is 23 and channel 48 and class is 115. So I can understand if channel is 48. Okay, so this radio is 5G. So so this is how we separate the radios, the bands. And I can also see the channel here, and I can also see the operating class. And that's it for the diagnostics part. Do you have any question regarding this? Okay, move on. So for optimization, you know, as far as I'm concerned, the optimization is different from the cloud perspective and the device perspective. So as far as ASIA, mostly related to the cloud operations, I am testing the optimization tools itself. So can I trigger the channel scan, or can I trigger the steering, something like that. So I didn't test, or I will not show the local optimization or the local logic of the prpLMesh, but instead I will show how can I steer a station, or how do I band selection for these stations. So this is for that. And at the end, I will show you the steering logs and steering events for these actions. So this is what I do. Let me open my data model again. Let me clear Ubas list and let me search my stations again. Okay, right now we have one station. Sorry, where is my station? Okay, one is here and one is here. I have two stations on radio to BSS1. Let's steer these stations to the extender 3, the device 3. How can we do that? So first of all, I need to know this station MAC. Let me call that. Okay, so this is the station MAC. Let me copy the macro for it. Okay, as you can see, we trigger client steering with station MAC and target BSS ID. And I want to trigger this to device 3, and I need that BSS ID. Let me comment that for a second, and let's check the BSS ID of device 3. 1 second, please. Okay. Okay, so this is the BSS I want to steer. Let me call. The BSS ID. And let me remove the comment. Okay, so it returned true, but let's check that it is reflected or not. I didn't see it triggered. Let me check the steering history for the device. But again, the prpMesh controller do some local optimization, and it affects my flow sometimes, like this. It triggered the BTM request on a device for better link quality, it says. For example, sometimes I face this. I couldn't disable the local optimization entirely to trigger the client string. Let's try again. Okay, let's trigger the other station. To the device 3. All right, let's see. Doesn't accept anything. Interesting. What should we do? Anyway, let me test it one more time. Give me a second, please.
I guess there are still a few wrinkles to resolve here.
We all know the situation when you want to really show something and it fails. So it's not unusual. Everything is fine, no worries. Well, it will work eventually.
You know, I tested this whole day before the meeting, and it was very good. And anyway, it shit happens.
Yeah,
Right.
like I said, just for the show of it, it wouldn't work.
Yeah,
it's all right.
Okay, let me try one more time, and if it doesn't work, I will not push my luck. Okay, so this station is connected to BSS1, and let me trigger again for the BSS2 on the same box first. Let's call BSS2 get. Okay, I will trigger this BSS ID. Let's see. So, sorry guys, it doesn't work right now. Something is broken. Anyway, so we can trigger client steering with destination BSSID and client MAC. And if it doesn't clash anything in local logic, the station should join to the other BSS. Before joining it, the controller sends a disallow message to all other BSSs. So they do not accept this station MAC. And then our station joins that correct target. If it fails, we have a log that it fails actually. So let's check that at least that our log shows the correct action for it. So as you can see, it fails, but I don't know why it fails. I need to check the log maybe. It is triggered from the Nordband API. We try to trigger this station from this BSS to this BSS. Normally, if it was successful, we should see that, okay, this is successful. And the time taken should show me how much second it take to steer that, the new target. And in these steering logs, we can collect all steering events in this data model. So that's it for the optimization part. Sorry about the broken steering test, but that's it. So I took a couple of notes here that maybe in the future these topics can be also be discussed and also be demonstrated, like local optimization, as I said. Maybe we can test a station moved around the office and it should automatically switch to the closest extender, something like that. Or we can add throughput tests, how these added extenders change the throughput, the values. We can add the stress test, what is the maximum connection of extenders, something like that. And we can show the prpLMesh RDKB, or we can show the NLA22 driver capabilities right now, what we have. Maybe at the end, we can show the Wi-Fi 6 support, traffic separation, hardware manager. And these are the future topics that we can discuss. And that's it. Thank you for attending and listening.
Quick question.
Of
Quick
course.
question. So what was the device that you tried to steer?
The Android phone.
Oh, okay. Because, you know, I remember that Apple devices are very stubborn when it comes to steering them.
Yes,
who knows?
Maybe. I can try a couple of more, but as I said, I tried it hundreds times, but it doesn't give me the response anything. It directly rejected, it seems. But it should probably clash with the local optimization tools. Anyway.
That's okay. No worries. We believe you.
Thank you. Any more questions?
Yeah, I do have one, and I'm not sure if it's for you or for someone else, but you mentioned the local optimization that's happening. Is there like plans in the future for that to not interfere with anything if, like, say you have a cloud controller or like a cloud sense?
Yeah, it should. Yeah, and we have a task for that, I believe. Normally, when we disable the local logic, it should directly accept the steering request from the Nordband API, and it directly reflected. But I have checked the code before the demo. If we disable the control logic entirely, it doesn't even accept these steering requests. So that's why I need to open the minimum, the local logic, but it again clashed with mine.
Got it. Okay, understood. Thank you.
Any more? Anyone else?
I have a question. So I think you controlling the actually configuring the EasyMesh credentials through the data element. Just wondering, because we do have the multi-AP data model parameter objects in the TR1 which seems supposed to be the one really providing the configuration. So I'm wondering what's the thought process on picking up the data elements as the configuration plane.
So I think that's actually something that we can answer. So we work together with the OBMap group to discuss which data models we should use, which part of the data model. And indeed, in Tier 181 at the time, there were several possibilities. So there were the data elements data model overlaps a bit with the multi-AP data model, and there were some bits and pieces in other places. So I think the decision was taken within the OBMap group to use the data elements data model and extend that where necessary, and then deprecate the multi-AP data model. I believe that's Tim. I think that's right.
Yeah, actually
Correct.
in 215, the whole multi-AP brancher tree was all deprecated. And then we just took the relevant objects and we put them in, just like you said, Frederick, put them in places in the data elements tree.
Oh, Tim, you said that the whole Wi-Fi multi-AP object tree will be deprecated.
Yeah, it was already. If you go on the USP technology.now, it's already been deprecated in 215. Yeah.
Okay, cool. Yeah, because I checked the broadband forum website, CWP website. In the 2015 it's still there, so that's why I'm asking.
Yeah, it's there. It's just deprecated. So
okay,
if you look at the actual objects, it'll say that they've been deprecated. Yeah.
Okay, got it. Thanks.
Yeah.
I have a question about the environment of the demo. Was it done with prplware 1.4 latest release, or?
We are using prplOS 1.3 here because prplOS 1.4 is not compiled with prplMesh correctly right now. We are trying to fix it, but this is based on prplOS 1.3.
Okay, thank you.
Sorry, I didn't wrote the prplOS version in the test setup. I forgot that. And I hope this is beneficial for the showing capabilities of prplMesh, and I hope that the demonstration is helpful. Arnold, what do you think? Are you here? No. Okay. Okay, I can stop sharing, and thanks for attending.
Yeah, thank you, Cihangir. That was a very well prepared and executed demo. So thank you for doing that.
You are
Thank
welcome.
you.
Thank you very much.
Thanks very much.
Very
Thank
nice.
you.
Thank you.
See you guys.
Yeah.